looking further into other types of bonds, remember that we had the nonpolar and polar covalent bonds. So we're going to look a little more carefully at covalent bonds and more specifically at metallic covalent bonds, which is a special type of bond. Remember that hydrogen has 1 electron in its outer shell. It can hold up to 2. This hydrogen has 1 in its outer shell and it can hold up to 2. So together, when they do get together, they typically will share those 2 outer electrons in their outer shell. You can barely see their path here, but it is there. So when we draw this, we are going to draw a line between the atoms showing a covalent bond. And again, if you remember our review, this is what a covalent bond looks like. It's when we get 2 atoms together and they share that last electron, or 2, depending on the configuration in the outer shell. If we do the dot diagram, we see that we have 2 hydrogens here, and with oxygen, we've got 6 in the outer shell. So there's 1 space here for oxygen and 1 space here for oxygen. So this hydrogen can easily bond here and share. This one can bond here and share. And so if we do the calculation, we see that oxygen is 3.44, while hydrogen is 2.20. Oxygen is the bigger one, so it is going to take the electrons. But when you do the calculation, you see that the difference is 1.24, which rounds to 1.2. So looking at our chart, it's only a 30% chance that it will be ionic. So because it's less than 50, we call it a covalent bond. And so often people say, well, what happens if it's 50%? And you'll notice when you look at your chart, there is no option for 50%. It's either right before 50 or right after 50. So I believe it's 47 and 51. So there isn't a chance that you're going to have to make that decision. So this is what the dashed line structure looks like for hydrogen when it bonds with oxygen. And basically the chemical formula, you know it as H2O. Now if we look at metallic bonds, remember that they occur when the outermost electrons are shared. So really metallic bonds are just covalent bonds. But the difference here is that both atoms must be metals. So when you have a covalent bond and both atoms are metals, that is when you end up with a metallic covalent bond. There is no such thing as a metallic ionic bond. And in fact, when you look at the percent ionic characters and those differences in electronegativity, you'll understand why. But here, you're going to have the percent ionic character less than 50%. Okay, so again, metallic bonds occur in the outermost electron shells when they're sharing them. And the atoms must both be metals, and the percent ionic character has to be less than 50%. And this is what it looks like when they're moving around the outer, the nucleus of the shell, of the atoms. Last thing here today, inert gases are also known as your noble gases. They are in group 18, but family 8. You'll see that they have 8 valence electrons in the outer shell. And so according to the octet rule, they don't need to do anything to be stable because they already have a full octet on the outside. And they don't bond with others because they don't need to. And those inert gases have no electronegativity because their outermost electron shell is filled. That's why most of the time you'll see their oxidation state number is 0 and they have no electronegativity number. And that's it for today. Thanks so much for joining us, and we'll